Hello and welcome to SAP TechEd 2020. I'm Vahid Bisadi and I'm a senior data scientist at CXAI Group. Today's session will focus on automated territory alignment with constraint optimization. And here is a brief agenda about the session today. I'll start with an introduction to CXAI Group and the type of projects we are working on. Then I'll explain the alignment problem, what the problem is, and what challenges it introduced to the sales management. And then after that, I'll provide a more technical definition of the problem. And once we know what the problem is, I'll discuss about the solution strategies that we try to solve the problem. We tried genetic algorithm, clustering, and capacitated routing algorithm. And the last one is the algorithm that we implemented in SAP Territory and Quota product. And at the end of the session, I'll show you a demo that shows you how we implemented the algorithm and some sample test cases. At CXAI Group, at SAP, we work on different products. We have CPQ, Configure, Price and Quota, Service Cloud and Sales Cloud, Commissions, Territory and Quota, Commerce, and Marketplace. And in these products, we have different types of machine learning projects. We have recommender systems, training administration, optimization projects, and hyper-personalization projects. And this session is about the automated territory alignment, which is implemented in Territory and Quota product, and we can consider it as an optimization problem. And here is a different view about the categories of the projects we work on. We have some projects for sales, sales performance management, service, commerce, and marketing. And the territory balancing and alignment is, we can categorize it as sales performance management. And with that, let's continue with the problem definition. And here is an example that illustrates the problem. Assume that we have 16 accounts and we want to assign them to 4 territories or 4 sales reps. And each account has 2 attributes. Each account has a revenue that is shown with a blue number and a call volume that is shown with a red number. And also each account has a location. On this figure, the location represents the actual geographical location of the account. And we want to assign these 16 accounts to 4 territories such that each sales rep has the minimum traveling distance. And also we want to balance revenue and call volume. It means that we have, when we have like the total revenue of 800 after the assignment, we expect each territory to have like about a revenue of about 200, give or take, and a call volume of about 23. And you can see even for this very simple problem, the best solution is not obvious, and it takes some time to figure out what would be the best solution. And I show you the solution here. Here you see the solid lines in different colors that represent each territory. And the solid lines, they show the best solution, and the dashed lines show the second best solution. And as you can see here, it's not very obvious what the best solution is, and even for this very simple problem. And usually the sales manager do these projects, do this type of problems manually, and it takes some time, especially when we have large number of accounts. It might be a challenging problem. So the manual approach that usually the sales managers do for this problem, it has some problems because it's time consuming, especially when you have large number of accounts and large number of territories. It would be really difficult to figure out with a good solution. And it's time consuming, and it can lead to infrequent rebalancing and unbalanced territories. And it's also not optimal because it is difficult to find the best solution manually. And any changes in the sales team lead to unbalanced territories. For example, if a new sales rep joined the team or a sales rep leave the team, the sales manager need to do the process again. And because it's time consuming, sometimes they prefer not to do it just for one change in the team. And it's also based on rule-based systems, and rule-based systems are brittle, which causes suboptimal alignment. And it's also difficult to evaluate. For example, if another sales manager wants to check the work, it also takes time, and totally it's a difficult problem, and it's also time consuming. So there is a need to for an automatic solution to save time and improve the quality and fairness of manual solutions. So here, let's have a more technical definition of the problem. We have a sales manager, and we have and she manages some sales reps, and she wants to assign the accounts to the sales reps. And each account has a different attributes like location, tenure, and up to 5 attributes that could be categorical or numerical. And the tenure refers to the time, the duration of time that the account has been working with the sales reps, if we have some pre-assigned accounts in our portfolio. So the sales manager wants to balance some of the attributes. It could be the number of accounts assigned to each sales rep, and it could be any of those custom attributes. It could be revenue, call volume, potential revenue, customer complexity, or any other custom attributes, and it could be categorical or numerical. The sales manager might need to minimize some of the attributes, like she might want to minimize the churn or the number of reassignments for pre-assigned accounts. And it means that if we have some pre-assigned accounts to territories, and if some of those accounts have long-lasting relationships with the sales rep, we prefer not to move them to a new account. And sometimes it's called minimizing churn or tenure optimization. And the sales manager might want to also minimize the distance traveled by each sales rep. So it's an optimization problems with some constraints, and we also might have some locked accounts. So for any reason, the sales manager might want to lock some of the accounts to some sales reps, maybe because they know the business better or any other reason. And sometimes the sales manager might want to group some of the accounts. For example, the sales manager might want to assign all the accounts in the same zip code to this to some sales reps, or she might want to group all the accounts in the same line of business and assign it to a sales rep because he or she knows that line of business better than the others. So we have some locked constraints and grouping accounts that we also need to consider in the optimization problem. Okay, now that we know what the problem definition is, let's continue with the solution strategies. We tried 3 different solution strategies. We started with genetic algorithm, and it's a powerful method, and it worked well with the problem. But when we added the distance constraint or minimizing the traveling distance by agents, it reduced the quality of the solution and also the performance of the solution. So we tried another method, that is clustering, minimum spanning graph, and balancing. In this method, we first use a clustering technique to separate the accounts geographically, and then we fit a minimum spanning graph to each cluster, and then we look at the territories and check the balance on them and see if they are not balanced. Then we move some of the accounts to come up with a good solution. And this methodology, it works well. It's a trial and error method. It works well for most of the cases, but for some cases that the accounts are not well separated and well separated geographically, and they have very different custom attributes, it doesn't work well. So the last methodology we used is a modified capacitated routing algorithm. And it's a combination of graph theory, traveling salesman problem, and a task assignment algorithm. And at the end, we implemented this methodology in the SAP Territory and Quota product. So I would like to give you more details about this product, this algorithm. So a capacitated routing algorithm assigns accounts at various locations to territories with a limited capacity for the least traveling distance. And in this methodology, for each territory, we define a capacity. We define several capacities based on custom attributes. For example, for the very simple example I showed you a few slides back, that we had like revenue and call volume. For each territory, we define a capacity for revenue and also a capacity for call volume. And the way we define it is that for the custom attribute I, we define the territory capacity I as the summation of custom attributes divided by the number of territories. For example, if the summation of revenue is 10,000 and we have 10 territories, then the capacity for revenue for each territory would be 1,000. And we have the capacity for the all the custom attributes for all the territories. And then we also have a tolerance term. If the tolerance is 0, we can get the perfect solution. But in real cases, for most of the cases, we don't have the perfect solution. So if we use the tolerance of 0, for many cases, we cannot find a solution. So the way we handle it, we start with a small value for the tolerance. We try to find a solution. If we cannot find it, then we gradually increase the tolerance term to come up with a good solution. And this algorithm has 2 steps. The one, what I explained is the first step. And then we also have a second step for assigning territories to the sales reps. So at the first step, once we do the process, we get some balanced territories, but we have not assigned them to the sales reps yet. And at the second step, we use a task assignment algorithm to assign those territories to the sales rep based on the tenure of the account. So we look at the combinations of, all the combinations of territories and the sales reps. And we see that if we assign a specific territory to a specific sales rep, what would be the total tenure of that territory? And we try to maximize the tenure of the territories using a task assignment algorithm. And in that process, we also should respect the locked accounts. If you have locked accounts if some of the accounts are locked, then we have some additional constraints in the optimization problem. And also, if we have some grouped accounts, we should treat them as one unit in the optimization process. So it's an optimization problem with optimization of distance and tenure. And also we have lots of constraints for balancing and locked accounts and grouping accounts. And with that, let's look at a demo that shows how we implemented this algorithm in the SAP Territory and Quota product.
This demo shows the implementation of the alignment algorithm in SAP Territory and Quota product. In this example, we have 29 accounts and we want to distribute them into 2 territories. Here we can select Optimize. And here you can see the existing assignment of the accounts. And as you can see here, the existing assignment is not balanced. So the first territory has 25 accounts and the second one has only 4 accounts. And the values of revenue and sales are not balanced as well. So to get a balanced solution, we have to select the parent territory that includes all the accounts, and then we can go to the next step. Here we can see the list of constraints, and the default ones are churn and workload. Churn constraint can be used when we have an existing assignment and we prefer not to reassign high tenure accounts to a new territory. And workload represents the number of accounts in each territory. And here we can add additional constraints to the problem. In this example, I add account value, which represent the revenue. We can add it to the model. And the numbers below each constraint, it shows the importance of the constraint. So if it's 0, it means that we don't want to consider it in the optimization process. 1 means that it has low importance, and 2 means that it has high importance. And on the right hand side, you can see some options for the optimization process. For example, if you want to log some of the accounts, or if you want to group some of the accounts by a specific attribute, you can do it here. And once all the settings are done, you can run the optimization, and you can see the proposed solution here. So for this example, the proposed solution is that the first territory has 14 accounts and the second one has 15 accounts. So the workload is balanced, and also revenue is balanced here. Revenue corresponds to the account value that I added as an additional constraint to the problem. And once you have the proposed solution, you can generate scenarios.
I hope you enjoyed the demo. And here I show you some sample test cases that we use to evaluate our methodology. This one shows 881 accounts in 7 territories in Los Angeles. And on the left-hand side, you see the output of the manual solution. And on the right-hand side, you see the output of the SAP Territory and Quota product with the automated alignment. And if you compare these two figures, you see that on the right-hand side, you see more dense territories. And if you compare the tables under the figures, you see that the total traveling distance on the right-hand side is much lower compared to the left-hand side. And in this problem, we try to balance account attribute 1 and 2. And if you compare two tables, you see that the account attribute 1, for example, it has a range of between 1.8 million to 3.5 million. But on the right-hand side, it's between 2.7 million to 3 million. So it shows that account attribute 1 is much more balanced on the right-hand side. And also, and that's the same for account attribute 2. And also finding the solution manually for this problem, it could take days or even weeks. But with the Territory and Quota product, you can get a solution in seconds or minutes. So it's much faster to use the automated solution. Here is another example. It shows 215 accounts in seven territories in San Francisco Bay Area. Again, on the left-hand side, you see the original alignment, the output of manual assignment. And on the right-hand side, you see the proposed alignment. And again, here, if you compare the numbers in two tables, you see that the total traveling distance is much lower on the right-hand side. And the account attributes 1 and 2, they have much more balanced distribution. And to summarize the advantages of the automated solution, we can say that it can reduce the alignment process time from days to minutes, or even sometimes the manual process could take weeks, and the automated solution can reduce it to minutes or even seconds. It leads to denser and more balanced territories, which saves time and fuel and helps the environment, and especially at this time that everyone needs to save the environment. It could be an efficient tool to reduce the traveling distance of the agents and save some energy. It results in more equitable revenue opportunities for the sales team. It can be done repeatedly with different scenarios to achieve these desired results. And it can also be used at different levels. You can use it at the state level, country level, or even global. You can use it at any level that you like. And I hope you enjoyed this session. And if you're interested in similar topics, please attend CX114. That session will discuss real-time business-to-business products and price recommendations, and it will focus on more details about the type of projects we are doing at SAP CXAI Group. Also, if you are interested in the optimization problems, you might want to attend CX112. It's about a scalable and general framework for optimization. And if you're interested in SAP community and products, please visit the URLs provided here. And I hope you enjoyed your learning experience at SAP TechEd 2020. And thank you for attending this session. Here's my email, and please, if you have any comments or questions, please feel free to contact me at vahid.bisadi@sap.com, or you can contact my manager, Nick Pendar, at nick.pendar@sap.com. Thank you very much.